Greetings, this is Michelle from Chrom Tech. In this video, we will discuss pore size and particle size in an HPLC column. When selecting an HPLC column, it is important to understand the different attributes and how they will affect your chromatography. Chemical properties, such as the type of surface of the stationary phase and pore size, affect sensitivity and retention. Physical properties of the column dimension, including particle size, column length, and inner diameter, affect efficiency and speed. Pore size is the average size of a pore in a porous packing. Its value is typically expressed in angstroms. The pore size determines whether a molecule can diffuse into and out of the packing. Therefore, the pore size of the packing material in your HPLC column is important, since the molecules must fit into the porous structure in order to interact with the stationary phase. Smaller pore size packings in the range of 80 to 120 angstroms are best for small molecules with molecular weights up to 2,000. For larger molecules with molecular weight over 2,000, wider pore packings are required. For example, a popular pore size for proteins is 300 angstrom. For polypeptides and many proteins, choose 200, 450 angstroms, and choose 1,000 angstrom and 4,000 angstrom for very high molecular weight proteins and vaccines. The choice of pore size must align with the molecular size of the analytes to achieve optimal separation performance. Particle size in HPLC columns refers to the diameter of the silica particles that pack the column. Smaller particles offer higher surface areas and thus more interaction sites for analytes. This results in better separation and higher resolution. However, columns with smaller particles also generate higher back pressure, which requires more robust HPLC systems. Larger particles generate lower back pressure and are often used in preparative HPLC, or for the separation of larger molecules. The trade-off between resolution and back pressure must be carefully considered when selecting the particle size for a specific application. The standard particle size for HPLC columns was 5 micron for a long time, until the mid-1990s, when 3.5 micron became popular for method development. More recently, as higher speed and/or higher resolution is required, chromatographers have turned to packings with sub-2 micron particle size. Selecting the appropriate pore and particle size for your HPLC application involves balancing various factors, including the nature of the analytes, the required resolution, and the capabilities of your HPLC system. For example, a researcher working with small organic molecules may opt for a column with smaller pores and particles to achieve high resolution and efficient separation. Conversely, if the goal is to separate large biomolecules, a column with larger pores would be more suitable. Practical considerations, such as column longevity, system pressure limits, and the specific goals of the analysis should guide the final decision.